Okay, let's do a video about time complexity. And I'm going to go pretty briefly over this. I could go into deeper detail than I am now, but this is just a general overview of O of n, O log of n, O of n squared, and O of 2 of n, 2n squared, and O of 1, or constant time. So the simplest one I could do is you could think of is as far as okay, if I'm looking at the time complexity graph right here, we see that we have for each O function, we have a level of time complexity. How long is it going to take to run this function? The best one being constant time O of 1, and then as you keep going up, the O of n factorial would be like the worst time. So let's do a constant function. I'm going to show you what a constant one would look O of 1 would look like. So O1. This is going to be really easy. So int get 1 element get. So let's do an array and you're going to pick the, I want to say get 1 element and then return array I. So let's make our main function. Let's make our boilerplate first too. Yep, that's fine. And now let's use this function. So let's first make an array. Doesn't matter what the numbers are, be any number. And let's get 1 element from our array. Let's get the element at index 4. So, index, let's do 3. And then let's print off the result. Oh, and I forgot to add the array to the function. Boom. The element at index 3 is 2. That's correct. Element at, let's try it, index 2. We get 4. We can see that the element at index 4 is 2. So that's O of n. I'm sorry. O of 1, and I put 0 here. I meant to put a 0. That's O of 1. That's what that looks like. That's the best you can get as far as time complexity. Now, let's try something else. Let's keep this array, but we're going to do something else. Find element. And this is the element we want to find. Now we're going to do 4. I is less than, and we want to get the array size. So as long as it's less than the size of the array, keep incrementing I. Then we're going to check if the array element is equal to the element we're searching for. And if it is, we're going to return the index. We don't need these things. We just do that. Otherwise, if we don't, we're going to return -1, indicating we didn't find anything. So let's try that. We're going to find elements from our array. We're going to with the size 4. We're going to try to find where the element 4 is in our array. found so it's going to tell us the index that it found the element for, and that's at index 2, and that is correct. So this is O of n, which is, you know, a little bit worse than O log n and worse than O of constant time. Now, now I can go into O of n squared. So when you have O of n squared, O of n cubed, you can basically think of it as how many nested for loops you have. So if there's one nested if there's one for loop, it's O of n. If it's O of n squared, that means there's 2 nested for loops. If it's O of n cubed, that means there's 3 nested for loops. But you do have to pay attention to, so if you're incrementing, right, then we can go to O of n squared, O of n cubed. Then it's one of those. But if you're doing something like O divide equal 10, then that is not O of n. That's O log n. So if it's not plus plus or minus minus, if it's not incrementing or decrementing by, you know, by 1 each time, then it's not O of n or O of n squared or anything like that. Yeah. So now let's do O of n squared. And for O of n squared, we're going to do something a little different. Yes, I can do multi-dimensional array. We can still return -1 if we didn't find it. It doesn't really matter the size. 2 by 3, why not? This is the element we're looking for. And then it's going to return it into these x and y pointers, the value that x and y values that we're looking for. And actually, wait, we can just do a void. Whoops, did that wrong. So, all right, so we can do something like 4. We'll say this part is x, and this part is y. That's how I'm thinking of it in my head. We already know that the size of x is 2. And then we can increment x. Another nested for loop, unsigned char y equals 0. This y is less than, no, the size is 3 plus y. And then if array x, y is equal to element, then return, nope, we're not going to return, I'm sorry. Then xp equals whatever x is, then yp equals whatever y is. So we're filling in those elements. And we're going to have to change our array a little bit to a 2 by 3. Say element 0 equals, I don't know, whatever values we wanted to add. Element 1 is equal to, doesn't really matter. The elements are, and we need what element we want to find. We could say 4, that's fine. We notice that 4 ends up, you know, shows up twice. It'll give us this 4. Let's say we can't have duplicates in this array. So just to make this example simple, let's make this a different number. And then we want to find our x and y. We can get, you know, initialize these to 0 and x and y. And I'm going to change our printf. It doesn't return anything. So it says it found it at where x is 0 and y is 2. Let's see if that's right. That's where it found 4. X is 0 and y is 2. Yep, that's right. Let's try another number. Let's try 5, see if this works. X is 1, y is 1, 1. Yep, that's right. That's where 5 is at. Yep, so that's that would be O of n squared. And if I were to do something where I had instead of a multi-dimensional array, but maybe whatever 3 dimensions is called, I don't know what the name of that is, to be honest. I don't think I've ever used beyond 2-dimensional array. Then this would be, if for some reason I needed to do this, this would be O of n cubed instead. So yeah, that's that. Now let's do O of log n. And to look at our graph again, we see that O of n cubed is slightly worse than O of n. O of n squared. Well, this says x instead of n, but yeah. So here we go. We're going to do O of log n this time. And this time we're going to do number width. So number width meaning if I have a number, let's say I have a number 1. How many characters wide is that number? Well, that's 1 character wide. What about 1, 2, 3, 4? That's 4 characters wide. Or how wide is this? This is 1, 2, 3, 4, 5. That's 5 characters wide. So we want to find how many characters wide a number is. So that's what we're looking for. That's what I'm calling number width. So I can do int num. I'm going to call this temp equals num count. Well, and then once the loop is done, we can just return count. So, oh, whoops. So if you look at this function, you know that numbers are, our number system is base 10, right? So if I keep dividing by 10, I'm going to slowly, so if I take, I don't know, this number, and I divide it by 10, then guess what? I'm going to get, here, I'll show you in Speed Crunch. If I take this number, divide it by 10, what do I get? I get the decimal moved up 1. Then I can do it again. The decimal moves up 1 again. Keep dividing, and the decimal keeps moving up 1 until we get 0. And in this case, because we're dealing with integers and not floating points, it just disregards anything to the right. And I think it rounds it. Actually, yeah. So that's kind of what's going on here. Just a simple visual representation. So let's do int width equals number width, and then just pick a number, 432. Why not? How wide is this number? I want to know. See if it gives us the results. 3. That is correct. It's 3 characters wide. Let's put a 1 in front of that. See if it knows. 4. 2. Yep. Okay. So that is O log of n, which we see is in between of O of n and O constant, O of 1. But we can do better actually with this function. So think about this. It's O log of n, right? We can use math. So I'm going to include the math header, and we can actually make this much better if we do return log 10. This is with a base of 10. The number is 1. And the reason, so I started the count at 1 because by default there's going to be, get Speed Crunch back. Keep getting Speed Crunch out. the habit. So if we looked at this example I did before, where I divided by 10, you see the first division, isn't counting the first element. So that's why I started off at 1. And in this case, if I do log with a base of 10, is kind of like dividing a bunch of times in a way, because the exponent is kind of like continuously, if this was exponential, it'd be, like times 2 times 2, kind of the same thing. Whereas if it was logarithmic, it'd just keep going like this, right? So it's kind of like the opposite of exponential. But anyways, so that's why I'm adding 1. Hopefully that makes sense. So I'm going to do log with a base of 10, and f is for floating point. And when it returns, it's going to disregard the fact that it's floating point and make it an integer and then add 1. Now this is O of constant time. And we see that we get a width of 2 with the number 14, about 143. And that's a width of 4. So keep that in mind when you're dealing with logarithms. We've seen that it was we had a O of log n, right? But because we knew it was already a logarithmic function, we could just literally use a logarithm to figure out the answer and get constant time instead of logarithmic time. So that's something you can kind of keep in mind when writing functions. Now, I'm not going to say that's always going to work, because sometimes you need stuff to happen during that loop while you continuously divide by 10. Because if you look at the source code for, what is it, ATIO, array to integer, I wonder, I don't know if it'll show the source code for it. But if you look at the source code for that, I'm pretty sure that it's O of log n. But yeah, that's that. Now, I'm going to go through one other one, and that's O of 2 of n. Now, when you think of recursion, there's a head and a tail. So when you write a recursive function, the head is what before you call the function again inside of the function, and then the tail is before whenever you call the function inside of the function. The head is after whenever you call the function inside of the function. And that might be a little confusing the way I explained it, but I'll explain it again. So let's make the Fibonacci sequence. So the Fibonacci sequence, which I'm pretty sure everyone's familiar with, is when you take the 2 previous numbers and add them together to get the current number. Now the first 2 numbers are just going to be incrementing like normal, but everything after the first 2 numbers is going to be the previous 2 numbers added together to get the next number. So you get 0, 1, because we're just incrementing like normal. And now we're going to add 0 and 1 to get 2. Now we're going to add 1 and 2 to get 3. Now we're going to add 3 and 2 to get 5. 5 and 3 to get 8. And yeah, it keeps going. So what we're going to find, what we're going to do is we're going to find at what index we're going to get that element. I'm thinking, yeah. So let's do that function. And fib, this is O of 2 the power of n. If n is less than 2, we're just going to return n. Otherwise, return fib. Yeah, so let's do let's try to find the third element. The element at third is 2. Let's try to find the element at index 4. You get 3, about 5, 5, 6. We should have 8. Yep. So based on the index, we can get what element is at that point in the Fibonacci sequence. Now this is what? This is tail recursion. So this is gonna be happening once we get greater than I'm sorry, on the returning point. But in this case, we're doing 2 levels of recursion, so it's O of 2 to the power of n. Yeah. All right, I think that's all for the video.